Okay, so we're going to do the power of a power rule. Let's see here, power of a power. Now, this has kind of three parts to it. We're going to have just a regular old power of a power. By definition, it looks like this. If you have a base with an exponent raised to another exponent, you're just going to multiply the exponents. So this would be x to the a times b. And that's the simplified, real quick definition of it. But because we can change this up, and I'll do it with examples, we can have, let's go 3 squared to the power of 4. If I expanded this out, now I would never do it this way, but by definition of the general exponent rule, that's really just 4 of these guys. And then, again, we can expand all those out, or we can cheat and use a product rule for this. So 2 plus 2 plus 2 plus 2 is 3 to the 8. So you could do that, or recognize if we backed it up, that we've got a power of a power. 2 times 4 is 8. A lot quicker doing it that way. But it really does just does come from the general exponent rule. So here's the extension now. I'll switch this up. This guy, if we went and wrote, let's say, x squared y cubed to the power of 4. This is what we would call the power of a product, because there's two things being multiplied. Now I'll do another example right after this one where it involves a numerical coefficient, but we can see that we can multiply the 2 and the 4 and the 3 and the 4, and we're done. Again, you could just expand it out and see that that's what the answer is, but if you can recognize that the power of a power, the x squared, is raised to the power of 4, but so is the y cubed, you can use that rule. Let's go with 5z cubed squared. So here's a pretty quick and simple one. Again, this is a power of product because you got multiplication. But this 2 does have to actually go into that exponent that's on the 5, which happens to be a 1, even though it's not really there, and that 3. So you get 5 squared times z to the 6, and we can evaluate that a bit further, going 25 z to the 6. Now that, ladies and gentlemen, is a pretty straightforward power of product question. Okay. I'm going to switch page here, and we'll do the kind of the second tier of this power of power, and it's called power of a quotient. So I'll just throw in an example. We'll use variables to start with. We'll say x cubed over y to the 4, and we'll raise all that to the power of 2. Again, it's just a power of a power, but because things are being divided, somebody decided to give them a fancy name called power of a quotient. We're just going to throw this exponent at that one and at the one downstairs and not change anything up, just x to the 6 over y to the 8 by multiplying those exponents. And simple. So do another one with a number here. Let's go with 2z to the 5 over w to the 4. And let's raise that all to the power of 7 just for fun. So when I use the power of a quotient rule, I get 2 to the 7, z to the 35, because I'm multiplying my exponents. That's how we got the 7 over top of the 2, because the exponent on that 2 is a 1, really. And then over w to the 28 when I multiply the 4 and the 7. And that's the power of a quotient rule. From there, you're done. So enjoy.